All right. Well, hello, everyone. Good afternoon. Thank you for joining us. We appreciate your time. This is our webinar. It's going to be handling a multi-data center deployment of a distributed cache. This is actually a new webinar for us. Quite a few of our customers have been deploying NCache in a multi-data center environment, so we thought it would be a good idea to put together a webinar on the topic. My name is Adam. I am a certified Scrum product owner and the regional director of service delivery here. So essentially, I'm the liaison between our customers using and evaluating NCache and our internal engineering team here at Alachasoft. With me is Ron, my associate. Ron is our lead solutions architect. He has over a decade of experience building enterprise applications. He not only hosts webinars such as this one, but he works very, very closely with our customers as far as deployments, demos, technical sessions to talk about their individual use cases. And due to his exposure and working closely with our customer, he's very pivotal in the roadmap of NCache and where we take the product. So you'll be in good hands today. You'll notice there's a questions tab on the GoToWebinar window pane. If you have any questions, let us know. I'll stop Ron from interrupt his presentation just to make sure all your questions are answered. That's what we're here for. So don't be shy. Let us know. And yeah, with that, I'm going to pass it back over to Ron and let you take it away.
Thank you very much, Adam. Thank you. Okay. Hi, everybody. My name is Ron. I'm one of the technical experts at Alachasoft. I'll be your presenter for today's webinar. So let's quickly get started with the presentation. As I've already got a confirmation that everybody can see my screen and hear me fine, so let's get started with this. All right, so the topic, it's a very important feature within the distributed caching product, that you may have multiple data centers, and then you have to have some scenarios where you have data requirements to be made available on each of the data center. So data available in data center 1 needs to be made available on data center 2, and vice versa. It could be active passive or active active. So we'll cover all the details around this. We'll talk about some requirements on the application end, some common use cases, different topologies that are available as part of this support within NCache, and then we'll have some hands-on portions, some demos with some actual applications, adding data on one end and retrieving on the other end, and vice versa. So let's quickly get started with this. First of all, I'll spend some time on NCache. I'll just explain what NCache is. NCache is a distributed caching product. It's an in-memory distributed cache. It's extremely fast. It allows you to formulate a cluster of caching servers. You team those caching servers together. So it's a team of servers instead of a single server. So you're already distributing your request load and data on multiple caching servers. And then it allows you to pool their memory and CPU capacity into a logical team or logical capacity. And then it helps you synchronize all your operations in such a way that all the servers are being used in parallel. You can add data at runtime, in real time, and all the updates on the cache are in a synchronized manner. So there are no race conditions, no data inconsistency issue, and yet you use multiple servers behind the scenes. It's linearly scalable. You can add as many servers as you want. So you can start out with 2 to 3 caching servers, and then you can grow capacity by adding more and more servers on the fly. And third, it allows you data replication and reliability features. High availability and connection failover support is built into it. It's very popular within .NET and Java applications. It's written in .NET, primarily for .NET, but you can also use it from the Java side of the things as well. So this is the typical deployment of NCache for a single site. You have a team of servers, 3, 4, 5 cache servers, and you can add as many as you want. Preferred platform is 2012 to 16 64-bit, and then you can have your .NET and Java applications connect to it in a client server model, and then you can have a database. Now this covers your single site deployment, so I'll just use this and jump right into the discussion here. So this is our single site deployment. What if we have more than one site? We have application which is geographically separated. We have many data centers which are working and supporting the same application. It could be applications which need users from a specific region, they are routed to a regional site, and then you have another region where users from that particular region are routed to that particular site. That is one scenario. Or it could be multiple sites for the backup purposes or for DR purposes. So I'll cover all these details within our multi-site deployment of distributed cache section. So that's next that I'm going to cover. Alright, so first of all, let's establish why do we need WAN replication of cache. You can have your distributed cache, your applications deployed in a distributed nature. There could be multiple data centers, but why is it needed that you have your cache to be replicated across data centers? Now, cache is all about high performance and scalability, right? So the use case for distributed caching is that you have fast access, and then you should have a capacity growing in a linear manner. You can have a lot of such requests, so latency should be less, throughput should be higher, and performance and capacity should grow as you have more and more servers in the cache cluster. And then if any server goes down, there's no data loss, no application downtime. When you have multiple sites available, or it could be a single site, one of the issues which NCache tackles is that if a server within the site goes down, it can take care of it. No issues if a server goes down from within one data center. So let's bring this application and cache deployment diagram in front. If you lose any of these caching servers, NCache already takes care of it, right? But what about the site level failures? If a site entirely goes down, if there was a power outage or there was some natural disaster, where it brings down entire site as a result of that, so you would end up with a single site, which is a single point of failure. You would have data loss, and you would also have your application downtime. So that is one requirement where you need WAN replication. You need all your cache data to be made available from the other site. Typically, if you have a data center where you have a DR site, and if you have database backed up over there, some of the tables are going to be there. But when you would start that site, you would have a lot of latency fetching all the data that you already had in the cache from the backend database. So that is the starting point where you may want to use it for DR site, where you have all the data in the distributed cache transferred across the network or across the WAN to the target site. Then it could be an active scenario where we have multiple regional apps which are hosting your applications. You have across the continent sites. You have a site in London, you have a site in America, you can have a site in Asia, or it could be within one country, but there are multiple regions. For example, you have New York, San Francisco. So there could be different cities where you have your applications deployed, and the idea here is that you cater for the localized traffic from within a region nearest to a region is hosted by that region instead of going across the network to another region or across the continent in some cases. So that is another scenario. Why do you need cache in that particular scenario? If you have your cache running, or if you have your data sources which are local, and that's the typical case in most of the scenarios, you would end up going across region for every single request. You have a user which needs some certain data, and that data belongs to another region. It's not available locally. It has to go across the WAN. So that can actually slow down. There could be intermediary network speed issues if the link is not that great because you're relying on internet for that matter. It can impact performance, and then it could be also the distance between these sites. So if data is not local, and if you have multiple regional apps, you may end up going across region and then fetching data which is available in another region inside your application deployment. So that would just slow down your performance and also hit the capacity. So you would end up with less throughput and high latency in that case. And then a solution to this is typically posed where you have a database in a central tier in one of the sites, and then other sites simply talk to the data source and talk to all other sources across site to the central site. So they go on every request, they actually make a WAN call. So that is something which is very expensive because you're dealing with a lot of redundant data. A data which was fetched as part of request 1, and if request 2 issues or tries to get the same data, it is going to go across the WAN again and again. So it on request level it becomes very expensive, where you're spending a lot of application resources, hardware resources, and most importantly, you're consuming a lot of bandwidth for every single request going across network. And this is a typical case for ASP.NET Sessions as well. If you have sessions data stored in database, or even in a distributed cache, you may have to go across networks, and that data is ever changing, right? And if it's a static data, if it's a reference data, you don't have a track between application requests. There is no store which is local to this site, and you go across the network and fetch that data. So this slows down things where you don't have data local, and it also eats up a lot of bandwidth and a lot of resources. So all of these we'll cover in quite great detail in next slides. We'll talk about how and what are the configurations that you can put in place to improve these issues, where it's not a single point of failure for some cases, if that's your use case. You have multiple regional apps, and you have data available on each site. It's not local to one site and remote to other site. And then for request, once data is brought into one site, you don't have to go across the WAN, and it should not be a cost incurred on the client side. So these are the challenges that we'll cover in quite great detail, how to resolve these challenges. That's something that I'm planning on covering next. Alright, so let's talk about some application use cases. So this disaster recovery site that is going to take care of any single point of failures. So with our bridge feature, that's our main highlight. You can use WAN replication, so it's asynchronous. The cost of replication is not incurred on the client end. It's done behind the scenes asynchronously by the bridge cache. So DR sites, that can be covered, so there would not be any single point of failure. You can have 100% data recovery if the active site goes down, and you route your traffic to the target site, and then target site would have all the data in the distributed cache along with the database. And we recommend that you copy your database alongside cache. So if you have a database mirroring turned on, just do that, and within your disaster recovery site, the target cache, you should have the active passive data flow turned on, and I'll show you how to do that. Then we have multiple regional applications sharing data and load, equal load sharing. Some data goes on site 1, some data goes on site 2, and this is also based on the application users, where they use their regional cache with location affinity. They have a nearest cache that has all the data that you need from the other cache, and similarly users on the other hand, they have all the data. So you have an active, but both caches are in sync, and you have the same data across data sets. You have local copy of data, and you never need to go across the WAN to the other site. Then east to west application data migration. A typical use case for WAN replication is that, for example, you have an application site on the eastern zone. For example, you have a site in Asia, and your users use that site, and as the daytime users, they make changes to the data, and that data is available in the cache. Now as your time zones change, that data needs to move across time zones, right? So it should be made available to your US to your Western users automatically based on this configuration. So data moves as your time zones change. So daytime uses data as soon as they reach the request load reaches to the western end of the world. You have your data made available as well. So that's another scenario where you can put in a WAN replication. So they still talk to the nearest cache, they have the data, but data originated from one end of the world, it's automatically being transferred to the other end of the world, and this is completely seamless to your end users. And then deployments, upgrades, maintenance without any downtime. So you can have multiple sites. One site can be used to host your application users, and at the same time you can have an alternate site which can be used to build the entire setup, and you can route all your data to there to the target site once it's upgraded, and then you can bring some of the users or all of them and then bring the actual site down. You can handle deployments, you can handle upgrades, you can handle monthly maintenances with the help of our WAN replication. And as a matter of fact, our live upgrade feature uses this behind the scenes automatically. So these are some use cases. Let's actually dig deeper into what NCache offers. So first of all, it's asynchronous replication across the WAN. So performance or redundant application calls, that has no impact on what is being transferred behind the scenes. So applications talk to the cache, and behind the scenes cache transfers data to this target site, and then there's another application which is talking to the target site, gets all the data. Similarly, if it's an active-active, clients talk to their own respective cache within their region with location affinity, and then they actually have all the data available on the other end. At any point in time after the WAN latency overhead, you would see that all your caches are in sync and they have the same data. Bridge itself is fault tolerant. It's a queue. It is also backed up. It's an active passive, so if active server within the bridge goes down, it would be picked up by the passive queue. And then it's very fast in terms of execution, and it's asynchronous, but it's very fast how soon it actually completes the processes on the queue. And then we have very high-end management and monitoring options. Very easy to set up, no code changes needed on the application, and then you have a lot of different topologies that you can choose from, and then you have complete monitoring and management support. I'll show all of these once we actually move into our hands-on portion. So there are two caching topologies for Bridge. You can have an active site, and then you have a passive site, and then you can link those two sites with the help of a bridge. Right, so that's our use case for DR sites where you have to maintain backups. We don't typically recommend this for ASP.NET sessions. Sessions are very transient data, but for any object which is of transactional nature or if it's reference in nature, you can choose to partition data within one data center where you have two kinds of caches. One is linked with the bridge, and you only transfer data to the target site which you actually need as a backup, right? So you can choose between data that needs to move from one data center to the other. So active passive topology, and then we have active active. In this we have both sites active. Cache running on one side is connected to the cache on the other end, and these are transferring data to one another. Cache transfers data to cache 2, and cache 2 in turn transfers its data to cache 1. So whatever updates you make here are going to be synced to the other side, and whatever updates you have on the other hand are synced back to the site 1. So it's an active active topology. You have clients running and you have active sites, and this is done asynchronously behind the scenes as far as replication is concerned. So this is our active passive topology. We have a cache running here, which is our primary site. So you have clients connected. You have a bridge cache, which is an active passive. It is going to be on one of the data centers, and then you can have the active queue, and then that queue is also backed up. And then you have our async replication link with another cache. So configurations are very simple. You already have a cache on data center 1, you have a cache on data center 2, then you just configure a bridge and then attach these two caches and make one active and the other passive. So it's a one-way data transfer from the active site to the passive site. And idea here is that if active site ever goes down, the passive automatically becomes active, or it's already running, so you start routing your traffics here. Or it could be a daytime user sending their data, or east to west migration. So it's always transferring from one end to the other end of the world. So this is your eastern cache, maybe in Asia, and then you have a lot of applications using this, and then you have a bridge which is connected to it. Whatever data is being updated here is automatically being transferred to the western region of the cache, and it's already running, right? You have applications connected here as well, but it's just that one-way traffic. So passive does not mean that cache is not running. It's still running, but it's not the one which is a source of another cache through bridge. It's just the target cache, and this is the source of it. So it's a one-way traffic, and this covers your DR side as well as east to west data migration. And also for this can also be used for maintenance or backup or upgrades. That use case can be handled with the help of this. Then we have active topology. In this, bridge can be on either of these data centers. It could be a separate data center as well, but we typically recommend that you keep it bridge on one side, and then you have a target cache. And let's take an example of a European application where you have a London region, you have a Frankfurt region, and then you have a Dublin region, right? So based on your location affinity, your users are using their respective caches. London cache is being used, then Frankfurt cache is being used, and then you link these caches with the help of bridge. London cache is going to transfer data to the Frankfurt, and then Frankfurt cache is going to transfer data back to the London. So at any given point, if your users need some data from one another, data load is driven by both sides, and data is equally divided, and then your user load is equally divided, and then they're linked with bridge. So whatever data that you have on this side is transferred to the other, and vice versa.
Quick question, Ron, just based on this picture, what is your recommendation for the deployment I mean, it looks like is the cache its own set of servers.
Yeah, okay. So as far as Bridge is concerned, Bridge, we support both options. You can have Bridge on the same servers where your cache is running, or you could have dedicated set of servers for Bridge. Our recommendation is to have Bridge on completely dedicated servers, right? So the whole point of Bridge is that it's transferring data from one data center to the other. And if it's a DR scenario, this side goes down, then Bridge can also go down, right? Bridge only takes data and it puts it in the queue, and then queue actually replicates it to the target site, right? So while some data is in the queue, and if Bridge goes down along with your primary site, you lose those operations. So we typically recommend that you have Bridge on separate dedicated servers. So if you need to do maintenance, or if this goes down, or if you have entire site wide maintenance that is needed, Bridge servers can be spared, right? They work on their own independent respective caching tiers. Bridge is just a cache with active passive mirrored, but the whole purpose of Bridge is that it connects cache 1 to cache 2 in an active passive or in an active manner. I hope that answers your question. Bridge configurations are very simple. I'll show you things in action, but just to give you an idea, it's a no-code change option. You can have your existing caches linked with the help of Bridge, and all you need to do is perform these configurations. And these are done through management tools automatically. So this is our Bridge configuration right here. Our name of the bridge is London NY Bridge. Then there are some settings, some queue optimization, some timeout, some connection settings, and then you have London cache and New York cache as active or as an active passive. So in this case I have active. So London cache is one cache that's connected to the bridge, and the New York cache which is also connected. So this is all what you need in terms of configuration of the bridge. That's how simple it is, and I'll show you how things work in action. So let's get started. Now that we've built enough details around why you need bridge, what are the use cases, and active passive and active would handle what sort of scenarios. Active passive is for DR. It's also for east to west data migration, and it's also for any upgrades, maintenance, or any patches that or new releases that you need to make. Similarly, active is for scenarios where you have regional traffic to the nearest cache, and then you want to have data shared between. You don't want to go across data center for region 1 users and talk to region 2 cache and vice versa. Okay, I have this environment set up. What I'll do is I'll show you the bridge in action. What I'll quickly do is create first cache, and then I'll link it with other two caches as well. So let me just I have two applications as well, so let me just quickly review what exactly are the names of the caches, right? So these are the two applications, London app and New York app. So these are the two data centers that will primarily be working with. So I have a cache name which this application is using, so it's a London cache. So let's create a London cache first. I'm going to use NCache manager on my first server. Let me actually copy the cache name so that I don't misspell it. Alright, so that's our cache 1. What I'll do is I'll pick everything default so that we don't have to go through a lot of changes here. I'll have demo 1 and demo 2. I can have one server, because the whole point of this is that you have one server and then another server on the other end, and then bridge. But you can have multiple servers within this cache as well. I can also have demo 2 as needed. So I'll just stick to demo 1 for now. Keep everything default, and I'll keep the default settings here as well. I'll just start this cache. Alright, so as soon as this gets started, I'll actually run my London cache and show you that this works. This is our London data app. The way it is designed is it's actually going to connect to this cache, and it would ask you to add some data. I need to actually, that's the URL for this. I hope. Okay, so this is our London app. It allows you to provide a number of items that you plan on adding, and then it would just make object caching calls and then add that data. You can see there are two fetch buttons. It fetches England data, and it also fetches New York data. So within this London side of the things, I'm only able to add London data. I'm not able to add New York data. So I'll just experiment with this. 10 items are added. Let's see if those items are added. There you go. And if I quickly show you what items are being added, let me actually just find dumb cache keys. Come on. So these are the 10 items. London data 10 1 to 9. So that's a simple data that I have just added in this cache, and then I'll fetch this, and we have 10 items added here. If I fetch anything from here, nothing is going to be retrieved, because this application is only connected to the London side. Now what I'll do is I'll start another create another cache, and I'll just name it New York cache, and for that I just need the name of the cache. So I'll come here, New York sample, and I'll open the web config from here. So this is our New York cache. That's the name that I need. I'll just create one. Right, so the purpose of this hands-on demo portion is that I walk you through cache creation on one side, cache creation on the other end, and then link those caches with the help of Bridge. As a matter of fact, let me actually log on to the other server instead of just showing everything here. That may sound slightly confusing, so let's just go to the other end of the WAN and then create a new cache, which is New York cache, and then just pick everything default here, and instead of demo 1 I'm going to choose demo 2. That's the second box that I have where my other cache is going to be running, and this could be across the WAN, no problems over there. You just need to have IP address and port to the corresponding servers where NCache is running. Keep everything default, and let's start this cache as well. Now my applications, again, this application New York app, that's actually targeting the other cache here. Let me just alright, so it's complaining that I do not have a client added, so let me just add that so that I'm able to connect. My applications are on one machine, so I just need to add that machine under the client here. Now I'm able to connect, so let's see if I need to recycle application or it will work automatically. There you go. Now if I fetch anything from London end, nothing is added in the cache, nothing is on the New York side. Now this cache adds 10 items on the New York side. Now again, if I come back to my original app, it's still not fetching anything because these caches are not connected as yet. It's fetching whatever you have here. If I just add 20 items, it would just update the existing one and then add new. It would fetch 20 items, but it would never fetch anything from the New York because this application is only using London cache. Whereas on the other end, this cache is this application is using New York cache. It's not able to fetch anything from the London yet, but it still can fetch anything from New York. And let's do that. Add data and then fetch data, 20 items. Now if I come back right here, we have 20 items here. So let's actually dump those so that we actually see. And then we have New York cache. There you go. So we have New York data, and that's exactly what is being printed on this side of the fence here. Now, first of all, I link this with an active passive use case where we would have London cache, the active side, and we have the New York side on the passive end, right? And the way it would work is whatever data that we already have in the London cache would move to the New York. It's more of from Europe to US region, or it could be from east to west region, and then we'll add new data here, and then you'll see that new data coming back into the New York site. But nothing would come from New York to the London site, and let's actually review that. Bridge creation is very simple. You need to right click on the bridge and choose create new bridge. Just name it something. Let's name it, it's something which is meaningful, right? And the bridge could be on demo 1 and demo 2, so it's an active passive. You can specify any server here. It's the queue of the bridge which is backed up, right? So don't get confused on the active and passive within the bridge. Bridge is also a queue, so bridge, if it goes down while it was doing some processing, some data was there, some operations were there, so it needs to be backed up as well. So that is done through mirroring of its own. Enable queue optimization, I'll talk about this, and then choose finish. Keep everything default. So our bridge is now configured, but it doesn't have any caches, right? So I need to add clustered caches here. So bridge is now started, actually running, created but not started as yet, and no caches are configured. So I need to add clustered caches. First cache is on demo 1, right? This is 107, and then it's the London cache right here. I want this to be active, and by the way, you can also choose an alias for this cache as well. If you have same named caches, you just need to specify alias here so that NCache Bridge does not get confused between the same named caches. You can even have same named caches connected through active passive and active active as well. So I'll just choose London cache to be my active site, and then I'll come back here, add the second cache, which is on second server, demo 2, and then I'll add the New York cache, and I'll make it passive. Right? Next thing that I need to do is start the bridge, and as soon as I start the bridge, 20 items here would be actually replicated on the other end. As a matter of fact, let's do one thing. Let's add 21 items, right, on the New York site, so that we have 21 plus 20, 41 items. So we'll have a difference of count as well. All right, I'll just start this. So as soon as bridge would start, it would take care of existing data. Right? There are some operations that it did. There are this is the active server. It actually performed 20 operations already. Now all I need to do is come back here and have a look at the count. Right? So it already has the data which is sent on the other end. If I just run this command again, now it has London data as well. And if I run my application on the New York application, if I now fetch items here, it fetched 21 items. If I fetch items here, it actually fetched London items here. But if I come back here and try to fetch New York items, it's not fetching it because it's a one-way east to west transition for DR sites, and you can run applications on the other side as well. Now let's add some. Let's make things interesting. Let's bump it up to 40 items. So 40 items are now in this side of the cache, right? 40 items, and you can already see some activity on the bridge, and it now has performed 60 operations in total. So I can fetch these items here. I still fetch something from the New York. It's one way from London to New York cache, so this application would not fetch New York, but application on the New York end should be able to fetch New York items and should be able to fetch 40 items from the London. Let me actually make the count even on both sides. So 40 items here, 40 items here. So we have all the data being transferred from the active side to the passive side. So that covers our active passive scenario. So any questions on this, please let me know.
A simple question. What happens if any of these servers in the bridge go down?
Okay, very good. So we have this mirrored. So if this goes down while it was performing, nothing is in the bridge as we speak. It's a queue. So something comes in, it actually transfers to the other side. So if something goes down, the other server would pick up automatically. So it's fault tolerant, 100% uptime scenario. Now let's take this example. Let me just clear contents here. Let me just come back here and then clear contents here as well, and make the active use case. Since we have about 25 minutes left, so I want to cover the second use case and then move on to ASP.NET sessions. Now making the active scenario is very simple. All you need to do is right click. You see there is this gray mark on London cache that's active, but this is not gray or more gray. In that case, all you need to do is make it active. That's it. Now we have both sites active. You could say make active or passive is not is disabled anymore, right? You can make it passive, but it's still working absolutely fine. Now all I need to do is fetch some data here, so that we don't have any items here. Similarly, we have 0 items here. Now I would like to show you the same use case. Let me just open this. This is our New York site, and then this is our London site, right? And let me show you the bridge and other cache statistics. Nothing is added here. All I would do at this point is add items from 10 items from London site, right? Fetch it. Actually, it's New York site. I'm sorry. So it should be here. My bad. I got confused with the flags. All right. So New York data has been added, 10 items here, but London data is not being fetched, right? Because nothing has been added from the London ad. Now that I've added this data, let me just fetch it from the London site, and we have the same items made available from this end of the world as well. Now let me add some items here. Let's add 20 items here from the London site. Fetch it here, and then let's fetch it here, and then you have 20 items here. So notice that I'm adding data in one cache, but I'm able to fetch it on the other side as well. Let me just add some more New York data so that we have the same count, right? Let's quickly fetch it directly from the New York data. This added, let's fetch it here. So 20 items are fetched here, 20 items are showing here. So at any point in time when you have data application going on, let me just show this while I have the bridge counters in front of you, right? Okay, so let's keep this bridge window in front, and that should cover the monitoring details within the bridge. So notice this bridge counters, the operation sent, right? So I'll just add some more data to the New York end. Just add some, let's say it's actually not updating any more data, so I may need to update the number of items that are already there. There you go, and you can fetch items here. That's right. So at runtime, at any point in time, you could see that the item count is 60 on one end, and then we have item count going 60 on the other end as well. Let me just clear the contents here, just show you everything from a standpoint where we started it off. Let's clear contents here as well, right? And then let me see if I'm showing the right counters here. Okay, so this is the counter that I want to show. Let me just fetch everything here, fetch here, similarly fetch everything here and here. We have 0 items. We'll start over. We'll have 10 items added on the New York end, and then we'll retrieve those 10 items here, and then you'll see that the count goes up 190, right? And then let's add some more items here. Let's see, 20 items here on the London site. Fetch that data here and fetch data here, and we have the same data available on this side as well. The count window shows up now 210 items, right? So this is very quick for me to actually show in real time, but behind the scenes it's actually making those changes. All I've done is link these caches with the we have the same items here with the same active bridge. Let's make the count stable so that we have the same items, and grids show the same values. So that's how simple it is to set up the bridge for data caching. And you can have one-way traffic, east to west, DR sites, and then you can also have maintenance where one site is transferring data to the other, or you could have active where data added on one site is transferred to the other, and vice versa. Now there are a few other things that I want to cover. It's highly available. Queue optimization, it actually optimizes the data redundancy in the queue. And then conflict resolution. Default conflict resolution is that if there are 2 updates coming at the same time for active, the last update wins. But it also gives you a pluggable custom conflict resolution as well, where you can plug your own conflict resolver, and it gives you an init method, and it also passes on all the 2 operations to a handler, and you can register this handler, which would be called at runtime. So you can put your own logic that I want this to be done through my code, right? I can review the contents of the object and then decide which update wins. So that's all for the bridge. I'll show you the ASP.NET Sessions use case, because that's slightly different than the bridge. Now for bridge, it could be reference data, it could be some data, but it's on the cache level. Whatever it gets added in the cache actually gets transferred. The challenges with ASP.NET Sessions, if you have 3 data centers and you have ASP.NET session data is very transient in nature, right? It's changing as you it's short-lived. It's only for the scope of current user, and as soon as user goes away, the data is also not needed anymore, and it's very frequently changing data. Now, if you have a bridge setup where you have cache 1 handling one region sessions, and then you have cache 2 which is also handling another region, and then you have a bridge in between, active passive or active active, and users are bouncing between sites, chances are that data which has changed on site 1, while you have transferred it asynchronously on site 2, it has already changed on site 1, so it's again changing. So it's an ever changing data because it's transient, because it's transactional. So it's not very good in terms of performance. It's very expensive to transfer session data across data centers through Bridge. So Bridge is not something that we generally recommend for ASP.NET Sessions. We discourage the use of Bridge. Primarily, it's because data is ever changing. It's very expensive on the bandwidth because you don't want to replicate an entire session object and then you replicate it, complete the replication, and end up knowing that you need to replicate again because it's changing so frequently. And then while you have replicated for the DR site, that user is not there anymore, so you don't need the backup of that anymore. So we don't recommend using Bridge. We recommend that you use our multi-site session feature. So let's talk about it, how it works. So this is the diagram which illustrates what multi-site ASP.NET Session deployment is. So in this, what we expect from your application is that you have a regional traffic. So if you have region 1 and region 2, those are 2 regions that you have, and then you have a cache hosting all your ASP.NET Sessions. We don't recommend having a bridge in between this. What we really recommend is that your application has a connection as a primary cache within the region, and it has a connection to the secondary cache in another region. You can see web region 1 connected to this cache, and then across the WAN it has a connection here. Similarly, this cache is connected to its primary cache, and then it's connected to its secondary cache. The whole idea is that your global load balancer would route traffic to this site based on the location affinity, right? But it would have a connection here as well as here. So your sessions would belong to the site where you would create them, right? If it's a London user, it would have all the sessions in the London cache. And if it's a Frankfurt user, it would have all the sessions in the Frankfurt cache. Now for overflow or for one odd request which bounces from one data center to another, user, and by the way, we maintain information on the request layer as well, on the cookies, that this request belongs to the London region. So if an already existing user which was on London site ends up on the Frankfurt end, where its session is not in its primary cache, which is right here, it has a secondary connection. So for one odd request, it can bring that session automatically. We have kept it on a request level for ASP.NET Sessions because ASP.NET Session is a very transactional in nature. We don't want every request to be handled in such a way, or all the data here to be transferred here, or vice versa. So what really happens is, if you have a user initially connected here, it creates session here. If this request goes to other site and session is not here, this client application would make a request across the WAN, one odd request, would fetch the session back and move it here. So next time it doesn't even have to go across the WAN. So this is an expensive trip across the WAN, which is not going to be for every request. It's not on the cache level. It's for the request which bounce from one data center to other. And this is what we recommend that you turn on. And these are the configurations that you need inside your applications. You set up the section. You have a session state already set up. Now you go from single site to multi-site session. All you need to do is set up this multi-site session section. In your London site, you have a London session cache. That's your primary cache. There is a site prefix as well. 4 characters are supported in there. And then secondary cache for this is New York session cache. So most of your sessions are in London, but if you have an active site where you have New York traffic, and all, or it could be Frankfurt between and London, so all the other traffic is handled through nearest cache on their end. London traffic is handled by the London session cache by the nearest users. Now if London user goes to the other site, if you bump it up, or if you have to have maintenance where you bring London site completely down, or it's because of overflow where capacity issues are occurring, or it could be one odd request which bounce from one data center to other, the New York cache New York session cache does not have your data, but your application having this setting is able to talk to the London cache and vice versa. So if New York session ends up on London site, it would bring it automatically from New York site and updates the location as well. So that's all what you need in terms of configurations. Let me quickly show you an application which supports this. Let me just close this down. Actually, bring it down. So we have two caches running again. Let me just we don't need bridge for this, so I'll just minimize this. So demo 1, we have our London session cache, right? And then on the other end we have our New York session cache, right? And let's clear the contents here. Now the way I've designed this is, if I just go to, right here, this is our London session app. If I just keep it on one data center, I'll show you one data center, and then I'll show you a use case where I'll put it in a load balancer and bounce requests. Every alternating request would bounce between servers. So this is a guess game application. It guesses something and then puts it in the session. It asks you to keep guessing the numbers, and it gives you the numbers between 24 and 100. So I'll just keep guessing until I end up on the right number. So this is just using everything from the London app, right? And similarly, we have our New York session app, which is creating a session of its own. I'll just create a new incognito window so that we have the session value, not using any cookies or anything, so that it has its own session in there. So it started a new session here, right? Right. So these are two sessions that we have. One user is on the New York end, and other is on the London end. So you can see we have New York session cache showing one item here, and then we have one user which is logged in onto the London session site. One user. Right. Now, what if this user goes to the other end, right? We have our London user going on the other end, and then New York user coming to the London end, right? So for that, what I'll really do is I'll close these down. I'll show you. You've noticed that our user remains on one site, but I'll show you a use case where I'll have these users bumping between applications. For that, I'll just use this load balancer, and then if I quickly show you the load balancer right here, it has, right, so we have two applications, 107 84 port and 107 85. These are the applications that I was running previously, and I'll just run this application here. So this is going to be a new session object. I've guessed a number. London app is the one, right? Let's make another request, and I'm expecting this request to bounce to the other site, and you can see the New York app, but it did pick the session from the last guess. Let's keep guessing. It did pick the last guess and previous attempts, and now it's on the London, right? So let's just bump it again. So it's alternating between sites, but it's still able to get all these session values from across sites, and both servers are being used. So within web servers or within data centers, if you have a regional traffic, you would expect that traffic to be handled within that region, but if a request bounces to other site, it will pick the session and move it here, right? So that session should be moved as we speak. Now we have two sessions. One belongs to, let me just clear this contents, clear the contents and then start over so that you could actually see this. Only one session gets created when I run this app. Let me just bring it one more time. Session is gone, so I would see the history. I'm on the New York site, right? So it started a session, and session is only on the New York end. Actually, let me just see. Actually, it was on London end, right? So the session is on London end. No session is on the New York end, right? It's 0. But now, if I just issue the command to bounce it again, I've designed this application in such a way that the load balancer bounces it between sites. So next request would go to New York, and I would see the same session created over there as well. It has actually been moved. Now we have the New York session. And if I quickly show you the keys for this, it's New York session cache. Right, so this is our session key. Let me just copy this and then bring it back to the London site. We have the same session right here as well. This is from New York, and then this is from London. So you could see exactly the same session on both ends, but the way it was working was that each time it actually bounces, it brings it from the other end, right? So I can again bounce it to London site, and it would just keep using the session each time it bounces. But typically it would not bounce that much, because that's not a recommended scenario. You would have a local regional traffic on one end, right? And then you would have some scenarios where you need to bring this site down. In that case, you would have all the traffic bouncing here. So if you keep the cache running, it would bring all the sessions here automatically on the request per request basis. So only active users would bring the caches here. Similarly, if one odd request overflows from this end to here, you don't have to worry about it. We'll just chain the location for that pump, momentarily, and would serve it from here. If that user again bounces back here, you don't have to worry about. So we don't recommend having a cache level request by request transfer of data for ASP.NET sessions. That's the use case for object caching, right? You use Bridge for object caching, for transactional as well as for reference data. But for ASP.NET sessions, because it's ever changing, it's very transient, it's very transactional, and it's very expensive to tackle every single request, we recommend that you use our multi-site ASP.NET sessions. And these are the configurations that you can rely on for that matter. Alright, so this completes our presentation. I'll just quickly go through it, reiterate what we've discussed. We talked about multi-site, WAN replication requirements, why you need it. Then we talked about use cases, where you can place it. Primarily it's DR, one way. It could be active-active with regional data, but with localized view of the data. Don't go across the network. East to west migration, one site transferring data to the other. As your time zones change, you move data, and then it could be for deployments, upgrade, and maintenance. Then we talked about what are the features of WAN replication within Bridge. It's topologies, active-active, active-passive configurations, and have given you the hands-on demo and some sample applications which were using this. Data transfer from one end to the other, and data transfer from each end using active-active. And then towards the end, we discussed that we need to have different approach for multi-site ASP.NET sessions. We don't recommend using Bridge for ASP.NET sessions because it's transient, it's transactional in nature, it changes very frequently, backup is not needed. So it's something on a site level, backup is not needed, and you may need to have a request by request, fetching of data, and that's too on the client end, not on the cache end, through our WAN replication feature, and then we gave you a demo of that as well. So I hope it was interesting, it was informative. Please let me know if there are any questions. Essentially, this is the end of the presentation as far as technical side of things are concerned.
Just give it a second to see if any questions pop up, and if not, we can wrap this up. Thank you, Ron. So thank you for joining us. We appreciate you setting aside some time. I hope it was informative. If there's any lingering questions, let us know. You can find NCache on our website for download and usage so that you can experiment it and get your hands on the actual product. We're also available if you want to talk to one of our solutions architects for just a technical conversation on your specific use case. We can do a more in-depth demonstration of the product. If you ever need anything from us, let us know. You can reach us at sales@Alachisoft if you have any sales related questions. And other than that, we'd love to hear from you and get a chance to speak with you again. So we appreciate your time and thank you.
Thank you, guys.